We're team number 3, formed by Ali, Dani, Edgar, and Maria, and we're going to talk about methanol production. Overview. The selected area of interest for production of methanol corresponds to energy production, which aims to make available sufficient primary and secondary energy sources. Through the past of years, methanol has become one of the most important compounds in the world, as it is very useful for the obtention of a great variety of products. IHS Markit reported that in 2015, methanol was employed at least in 11 different areas.
Methanol is involved in energy production as it's an attractive emerging fuel for use. This is because it has been demonstrated to be a viable replacement to oil as a fuel, so as a more environmentally friendly way to improve its performance. Also, properties of methanol become it an even more interesting resources as it has possesses low heat value along with low lubricity and flash point. Another important information about the methanol is used in different types of industry, as a dissolvent, for example, the coat industry, the pharmaceutical industry, and in the plastic industry. It can be used as a raw material in the fabrication of formaldehyde, also in the fabrication of domestic products like surface cleaners, varnish, shoe polisher.
First of all, our team decided that the energy area would be the best option for this project. According to Methanex, methanol is considered to be energy, as nowadays it is used for direct gasoline blending, for the obtention of olefins and biodiesel, also for dimethyl ether, and for power. This company, Methanex, affirms that methanol can be produced using coal, natural gas, municipal waste, biomass, or recycled carbon dioxide. Then they informed that on an industrial scale, the major part is produced from natural gas. And well, this process consists on the reformation of the gas with some steam, and then it proceeds to a conversion and distillation of it in order to create pure methanol. And they inform that the result is a clear liquid organic chemical that is water soluble. The production of methanol is increasing every day. That's why there are at least 90 methanol plants around the world. These represent a production of 138 billion liters. And according to IHS, the global methanol demand reached the 91 billion liters. This number represents a 254 million liters of methanol consumed per day. And this methanol industry is present in Asia, Middle East, North and South America, Europe, and Africa. The global methanol industry generates 55 billion in economic activity each year, while creating over 90,000 jobs around the world. So we can see that there are many companies involved in this process. For example, Enerchem from Canada, Sunfire, Biosyntha, Sequence, Antasy, and Protabit.
The chemical reactions involved in the methanol synthesis process are usually divided in two stages, which are tree reforming and the CO2 hydrogenation. The tree reforming stage, basically what it does is obtain hydrogen and enough carbon monoxide to be transformed into CO2. These gases usually are hydrogenated 50 to 100 bar. The heat transfer in the reactor and in these stages are usually neglected because they don't really affect the calculations given the high temperatures of the process, and given the reaction rate is usually calculated using HISIS or some other software. The main reaction we're going to focus is going to be the CO2 hydrogenation. Given the already well-known data for this reaction, because we know from experimental data that this reaction is a first order reaction, and this can give us enough information to obtain our calculations for reactor design, such as volume and conversion aspects, which can be maximized with the help of Aspen HYSYS or some other software available. Methanol synthesis process usually is taken in gas phase. So our team decided to design a plug flow reactor, or better known as PFR, given the advantages it offers in terms of conversion and volume. Well, volume optimization in terms of practical terms. We could use a CSTR reactor because it is usually highly accurate in terms of ideal reactors, but a PFR would be as good enough, or even more, given it can actually give us better approximations to equilibrium, and this could give us more data to adjust our conditions to obtain a higher conversion. Now, for the kinetics of methanol synthesis process, we know that a common proposed mechanism is the synthesis of methanol with a formyl and a methoxy species that finally evolve into methanol. These mechanisms involves metal cations, which are our catalysts, and a backend zinc and or oxygen sites for adsorption. This means that methanol doesn't really get in contact except for charge differences with the catalysts. However, this mechanism seems to be outdated, as, as there has been a new mechanism proposed for nearly 2 decades which involves carbon dioxide as a necessary intermediate.